Okay, I think I've decided to go back and quickly go through the first 10, which I'm pretty sure we've done, and then I'll slow down for the ones that you haven't done yet. Number 1, which of the following correctly initializes an array? So this is just the way you're supposed to do it, and that's okay. That's the initializer list way, and it does assign 0 to everything. A new int array done this way, int array is assign new int 4 is fine, assigns everything to 0. And this one loops through properly and gives each one 0, so the answer is E, 1, 2, and 3. Number 2, the following program segment is intended to find the index of the first negative integer, where blah, blah, blah. So this would take a little bit of tracing, but since I'm just quickly going through the first 10, the answer is it works as long as there is at least one negative integer. So D is or I guess C is the answer. It works when there's one negative integer, so just picture it as being the third. So we look at the first, and it's greater than 0. We look at the second, it's greater than 0. We look at the third, and it's not greater than 0. Well, that's where the I ended up, and we return the I as the location. But if we went all the way to the end and there were no negative integers, if we got all the way to the end, so let's say that the length of this was 5, and we got to index 4. We look at index 4, be greater than or equal to 0, so our index will go up to 5. Then we loop back up here and we try to look at index 5. Well, for a length 5, there is no index 5, and so we would get an error. So C. Number 3, refer to the following code segment. You may assume that ARR is an array of int values. So it's summing, going through and summing, getting a total. But there's going to be a problem. And this is kind of a sore thumb once you get used to these kind of questions, because so many of these kinds of questions, the problem is that it's going to go one too many. And this is definitely going to go one too many, because just think about it. When we get I is less than, not less than or equal to, but is less than ARR.length, the I goes up 1 before checking what's there. So if we are at, just like the last example, say that the length is 5 and we're at element 4, well, before we check, we have I go up by 1. And so we're trying to check element 5 in a length of 5 array, which is an error. The I++ should be after. We need the I++ so that eventually this becomes false and we traverse through the array. But the I++ cannot be before checking the value, otherwise we're going to check a value that's not there, so this will be a runtime error. Number 4, and remember at this point that I'm just really quickly going through these first 10 or so because we've done them in class. So quickly, and this is not able to be done quickly with tracing, but tracing would definitely, over 3 minutes, give you the correct answer. So let me just jump right into what the trick of the question was. The trick was that we're making this new array, array 2, and then we want to know what it contains. Well, how big is array 2 going to be? It's going to be whatever count ends up being. And count starts at 0. Count only goes up when the element in the original array is not equal to 0. So here's the original array. And the I value, the element is not equal to 0 1, 2, 3 times. So count will only be 3 by the time you get to the end of this for loop, which means that you're making an array 2 which is only 3. And there's only one which is 3, and that's A. Number 5, consider this program segment, which basically loops, but it loops in a non-standard way. And if this is less than some value, print small, and says what's the maximum number of times that small will be printed. Well, it doesn't really matter what the value is. It's just asking what's the maximum number of times. What's the maximum number of times that this loop will execute? So this is a question about this loop, more than it is a question, frankly, about arrays. But anyway, well, you can try it. That's the easy first way. How about 5? If we had 5, we'd have 2, 3, 4, and 5, so we have 4. So there you go, that's your answer. 4 is 1 less than k. And you can reason that out just by looking at this, by realizing that we're not going to be printing for the 0. We're not going to be printing for the 1. So that's going to be 2 less than a value of k. But we actually are printing for the value of k, so that's actually plus 1. Then 1 more than we're normally used to. So missing 2, adding 1 that we're normally used to, so that's going to be the k minus 1. 2 different ways of seeing that answer. Again, I'm doing them quickly until we get to number 10. Number 6. And this is another one that I probably need 2 minutes to properly trace out. And if, with all these where you can trace, if it's asking for the output, if you trace them, you're going to get the right answer if you take the time to trace them. But the point of this question, as you may recall, the main point, other than tracing, is the fact that we're sending an array as a parameter down to a method. And the method does something with it, it changes it. And the point that's being made here is, or the question, turning it around, that it's asking is, if we send an array to a method and it changes, are those changes reflected back in the original array? And the answer is yes, because arrays are objects. So both this and that point to the same thing. So whatever is done down here is also done to the original array. So you go through and you trace it out, and it's not that bad of a trace, but it's still probably 2 minutes to take your time, and you end up with, let me just check what the answer is, 1 and 3, C. Number 7. And actually, number 7 and 8 go together. They go together because, as you'll recall probably, the first question is mainly looking for the advantages of array list, and number 8 is looking for the advantage or the advantages of an array. And so basically you're looking for the main advantage of a list and the main advantage of an array. The main advantage of a list is that it is efficient with adding or deleting, or inserting in fact. And the main advantage of an array is that you can binarily search it. So, taking number 7 first of all, you look through the answers, which again I'm not going to take the time at this point in the video to do, and the one that jumps out as being focused on resizing and so on is D. If any of the particular text file is unexpectedly long, the array list will automatically be resized. Automatically. The array, by contrast, may go out of bounds, and it may if you're trying to resize it. So this is the only one that talks about the efficiency and ease and lack of problems with inserting or deleting or modifying the length of the list, D. Meantime, you'll probably recall that with 8, there is no answer of the 5 that talks about directly a binary search. So you look for the best other one, and the best other one, A. An array of primitive numbers is more efficient to manipulate than an array list of wrapper objects that contain numbers. I'll explain that after I go through why the others are incorrect. Insertion of new elements into a list is easier to code for an array than for an array list. No, it's not. That's what an array list is all about. It makes it easier to insert new elements. In fact, it makes it possible to insert new elements. Same thing with remove. Removal of elements from a list is easier to code for an array than for an array list. Again, no, it's really easy with an array list, and it's difficult with arrays. Arrays are not meant to have elements removed. So those are both things that are good for array list, not for arrays. D, accessing individual elements in the middle of a list is easier for an array than an array list. Well, searching for elements in an array, if it is sorted using a binary search, is. But this is not talking about a binary search. This is just assuming you have a whole bunch of elements in an array and you go searching for them. Well, you're going to search for them sequentially. Whether it's an array or an array list, you're going to look for what you're looking for one after the other, and it's no more efficient in one than the other. And then E, accessing all the elements is more efficient in an array than an array list. So accessing all of them, same thing. You've got to either loop through them all in the array list or loop through them all in the array. So none of those are good reasons to use an array. This one is because, and I'm teaching this all over again here, making it maybe too long, but primitive numbers are they're just the number. There's nothing else. There's no baggage, as it were, that goes with them. They're not objects. And so they are more efficient because they're just more streamlined than ArrayList objects, which are wrapped in their wrapper class. So the answer is, for 8, A. Nine through 12 deal with this, so let me talk through it first, and I do think we got here as well, so I'll go through this quickly. That, yeah, your address, which includes the name, has its attributes, accessors, so you can get them all, and constructors which aren't shown. And then the idea is that the student includes a couple of primitives, but includes an instance of, so each student includes an instance of an address. So each student will have a name and a street and a city and a state and a zip, but only accessed via the address object that is part of it. And so then you have the constructors and accessors, and that's basically it. So these questions will be how to primarily access stuff through dot notation via an attribute of an instance, which is an object. So, number 9. And it's not dealing with the student at all, so it's just dealing with the address, and the address has got a name. So this is a question more about list than dot notation. So you've got a list, which is an array actually, and then you're using the for each to loop through it. So the first question would be, although it doesn't look like they're giving us a potential error, but you can do it. I'll just point out here because we're going to get to this later on. In these questions, that yes, you can access and print out stuff from a list, and that's what we want to do. So we just need to access each one of the names, and the proper way to do it is going to be, since we're using for each, we're just looking for something that has a, not this stuff, but just the a, and then it is get name. We don't have to put list because we already have list there. So the proper way of accessing stuff from a for each, there's the variable that we're using of the type of the list dot get name. 10, and now I do remember that we did this one as well, so we must be getting close to the ones we didn't do. So the thing is, you've got a for each, and you just can't use this chunk chunk notation with for each, so one's out. This one will work. There's your ADDR, and we're printing out the full address, so we want to get the name, the street, and the city, blah, blah, blah. So that's fine, and then the question is, will this work? Well, this is an object. ADDR is each one in turn of these addresses, it's an object. And print line can be overwritten to print out an address in a certain format, but it wasn't. And I won't bother scrolling up, it just wasn't. If you looked up in the address class, it's not. So the only one that works is 2. Give us the answer B. 11. So now we're getting into something which will require the dot notation to get to the second level, as it were, of what we're trying to get. We want to print out the list of student names, but we have an array of students. Student does not have name, but it has an address, which through dot notation, we can use the get name to get the name. So that basically says it all. We just need to look at what is the answer that does that. There's our student, so we're looking for student dot get address dot get name. That's it right there, C. 12. And I hope we did this one too, because I don't really, this is one of those ones that would take a lot of tracing, but you'd get it again, you'd get it if you traced it, but there is a secret to this one, and I'll just jump right to it. And that is that the question I haven't read yet, that we're looking for the student with the highest ID. So we're looping through in different ways with each of these. We're keeping track of a max and changing that max when the condition is that we found something that's bigger. The problem with 1, and there is a problem with 1, is that it returns the first student that we find who has an ID number greater than the original max. So there's the return statement. It's not it's at the end too, I suppose, that if This would work, in fact, if it were the student 0 that had the highest index number, because we finally get to that one and return it. But if we're in the middle someplace, we take the first. Even if there's something after it, we're done, because as soon as we find 1, which is greater than the max, then we return that student. So 1 doesn't work in all cases. And then I do believe that both of the other ones worked in different kinds of ways. I'm going to check the answer. Yeah, they both do. So again, since I think we did it in class, I'm not going to trace it. I got lots of tracing ahead of me here coming up shortly. So E. Maybe we've done more than I thought. 13 to 15. I'm pretty sure we've done 2. So we've got a ticket class. Pretty straightforward. And a transaction class, which is a little bit more complicated in that one of its attributes is an array of tickets. So the idea is that a ticket is a single ticket, row A, seat 32, 200 pesos. A transaction is a bunch of tickets. So dad goes to the baseball stadium and says, I want tickets for my family, I want 3 in this row and 3 in the row and back of it, blah, blah, blah. And I'm sure we'll have to look at this more shortly, but just the general structure is a transaction has an array of tickets. 13. If I recall correctly, this is just pretty straightforward. Initializing the ticket list array. So we have a ticket, the constructor to initialize the ticket list array. So we're already looping through, and the user inputs a row and a seat and a price, and then we make a new ticket, and we add it to the array. Okay. So we make a new ticket, and we're not going to use get row, get seat, get price, because it's going to be the row, the seat, the price, which they manually would have typed in here. Right, so there's a ticket list. And yeah, we're going to get new tickets. So it's going to be B. 14. This is the calculate. So we're looping through the ticket list. So these two are just wrong because they're not looping through the ticket list. These are looping through the ticket list. They're saying for each ticket called T that is of type ticket list, what are we supposed to be doing? We're supposed to be adding the price of the ticket. So it's going to be the T.get price. That for all the tickets, for each ticket T that's part of the ticket list, the total is going to be upped by that particular T dot get its price, C. And I don't think this is that bad of a question. Suppose it is necessary to keep a list of all ticket transactions, not a list of tickets, but a list of transactions. Assuming there are num sales transactions, a suitable declaration would be, well, it's going to be a transaction array. So a transaction array called whatever is a new transaction array of num sales. That's it right there, A. Transaction array, transaction, right, A. So I think probably now we are at a point where I'll slow down, and these have not been done in class. Actually, you know what I've decided to do? I think it makes sense to chunk this up into 15, 15, I guess it'll be 10. So finish with the first 15. I'm pretty sure in block F that we covered those in class. So I'll stop the video now just to make sure everything worked, if for no other reason, and start the next video here at number 16, where I'm not just going to quickly go through them relatively quickly. I'm going to actually trace through and explain thoroughly each of these questions. So it'll be a different style. So let me stop this now.